Hello and welcome to Teachers. Today we are going to see a new concept known as a palindromic number. So before getting in how to solve a palindromic number, we're going to see what a palindromic number actually is. Uh, so I've got a palindromic number. Let's say I've got number say 121. So what actually is a palindromic number? A palindromic number is something, a number which when reversed is actually the original number. Let's say I've got a number say 121. So when I reverse the number, it says 121. So what it does, what's a palindromic number is a number when reversed is actually the real number. So how to solve it? How to do it? What are the steps? What are the conditions we're going to see in this video? So stick with me and we're gonna make it interesting. And, so we start it right now. So first we're gonna include the header files for this. We've got nice. We've first what we've done is we've included the header files for the standard input output. That what stdio.h stands for. It is standard input output. If you don't know what that means, now we've got a main function. We need to declare the main function. We're gonna do the main. We're gonna do the entire process of this entire process of this palindromic number out in this main function. So what I've got is this main function. So let me declare the number which I want to input from the console. So there will be number, a lot of others, a lot of other variables as well with this. So we're just gonna leave this space blank out here. Now what we'll do is we'll try to print a message for the user to enter a number. Enter a number. We've got the number. We've got the message printed. Now we need to scan it. So we've got a scan function, and we're going to scan it with the help of scanf, because a user needs to input it. So we've done the input part right here. We've taken a number n, we've printed a message, enter a number, and then what we're gonna do is we're gonna scan the number, %d for scanning an integer type variable, and n. Now what we'll do is we'll try to get a backup for the original number. Why I'm doing it? It's because at the end I want to check whether the reverse number is the reverse number is equal to the original number. Like 121, I'm reversing it and I'm storing it in another variable. So let's say reverse. So I need to check it. To check, I need to have the original number. So I don't want to hinder this original number n. So I'm trying to get a backup of this number n in pk. Declare it out here, pk backup. So what the main process, we'll try to do it in this on this bk variable which has a backup of the number n. I'm gonna do a while out here, while bk is not equals 0. Why I did it? Why? I'm gonna tell you in a bit of a moment. First, let me just write it. while bk is not equals 0. That's a condition. It means our while loop will run until bk, that's a backup of the original number, is not equals 0. So let's say we've input a number, we've input 121, we've input the number say 121, so a backup will have the number 121. Now a backup is not equals 0, that's true, it is not equals to 0. So we're going in it, we're going in the loop. Now what I want to do, since it's a 3-digit number, we want to extract, before we will reverse it, we need to extract each and every digit of this number rather. I want to extract 1, then 2, then after 1. So how to extract each number? How to do it? Let's say I've got a variable d. In that I'll take the backup and I'll take a modulus and modulate or do it by 10. What does modulus do? Modulus is basically will return us, will give the remainder values. If we got 121, since it's an integer number, there will be no decimals, so that's 121 divided by 10. That will give us 12 in the quotient value, and in the remainder we'll have 1. So the value of d now is 1. We've input 121, we've taken a backup, we've created a while condition. While bk is not equals to 0, it will run because it's true. Then d is equals to bk modulus 10. We've extracted the first digit, that's 1. We've got d equals 1. Now what we want to do is we want to reverse. We want to keep adding each and every number to the reverse. Say I've created a variable r which denotes the reverse of the number, and I want to add it. We're going to add it each and every digit of the number to this reverse, so that the first digit, last digit of the last digit of 121, that is 1, will be the first digit of r, that's a reverse number. How to do that? How to make it? We'll do it by using, let's say I've opened a bracket, we'll do it r into 10 plus d. How? Why we do it? Why we did it? Why r into 10 plus d? Because, let's see, why are we doing it? Stick with me. We've got first we had d is equals 1. So now what we'll do, r we'll declare it first. So we've got d equals 0, and we've got r equals 0. Because of the garbage value, we don't want any garbage value. R equals 0 and d equals 0. So we're assigning a 0 first. So our initial value of r is 0. So 0 multiplied by 10 is 0. 0 plus d. So what our value of d is now? It's now 1. So 0 plus d, that is 1, is 1. So what we now have is r equals 1. So r equals 1. The next step is that now we've got extracted the first digit of the number 121, but after extracting, what we'll see is that the 1 will still be there. So we have already extracted the number 1, and I don't want to extract it again. I want to extract the second number, that is 2. I want to extract this, extract the number 2. So what will I do is that I'll try to remove the last digit that we have extracted or have done extracting. So to remove it, what I'm going to do is bk is equals bk slash 10. Okay, so it's just removing the last number. Okay, now since bk is equals bk slash 10, this slash is divide, it will return the question. 10 divided by 121 will give us 12. So we have removed the last number. This is, we are doing this for removing the last number, removing last number, removing last number. So now bk is equals 12. So 12 goes back to this condition. bk is not equals 0. It's true. It comes back. It comes back. Now d is equals bk modulus 10. So what I said was modulus. What modulus does, it's just gives the remainder value. So we are doing dividing it by 10. So remainder value will now be 2. So now remainder value is 2. D is 2 because modulus gives us the remaining value, and what I did was bk was 12. So 12 modulus of 10 will give us 2. R was already 1. So R1, that is R is equals 1, means R1 into 10 is 10. 10 plus D. D now is 2. D now is 2. So 10 R into 10. R means 1. 1 into 10 plus D. So 10 plus D. D, that is 2, will give us 12. See what I did there? What I did was take out this number. What we did before was we had taken out the last number of 121, and we had added it to R, the first of reversed number, and now we have taken 2 and added it to the second digit of the reversing number. Then again bk is equals bk slash 10, means it will remove 2, because what slash is, it gives us the question value. So 10 divided by 12 will give us 10. 10 divided by 12 will give us 1, because bk and all the variables used here is integer, so there will be no point of decimal. So it will give us whole values, whole number values. So 1. Now bk is 1. Okay, so bk is 1. Then again bk is not equals 0. bk is not equals 0. It's true. It will go to d. bk is now 1. 1 modulus 10 is, the remainder will be 1, because 10 modulus d divided by 1 is 1. Sorry, the remainder will be 1. My bad. Then what we're doing is now the value of d has changed from 2 to 1. Now what we have done here is, now r's value is now 12. Okay, so 12 into 10 plus d. 12 into 10 is 120. 120 plus, we are adding the last digit d, that is 1, which will give us 1, 2, 1. Now we are removing bk equals bk slash 10. Now we've got it, and now its bk is equals 0. So its condition is false now, so we'll come out of the loop. Now we've got the reversed number in R. What we'll do now is trying to check if this reverse number is equal to the original number, that is n. That is this one. Okay, so a condition will be if sorry, not bk, our reverse number is r. So what we'll do, we'll take r and check it with n. So our r is a reverse number and n is the original number. We don't need backup anymore because we had what we've done backup was just to take a backup of the original number n to the operations on. So if r, that is a reverse number, is equals n, that's the original number, we would like to print a message that we want to print a message that that the number is a palindrome number. Palindromic, where it go? Palindromic number, and you can print the number that is n, and so we've checked the condition r is equals n. If it's true, means we have taken an example of 121. We reversed it out here. If this original number is equal to the reverse number, then the number n is palindromic. Then we'll print the number along with the message the number is palindromic. Or else, if the number is not equal, okay, is not equal, we want to print a caution message that the number is not palindromic. Oh, palindromic. Have I got the spelling right? Palindromic, yeah, I've got the spelling right. So we've got a colon. So that's a code. First, let's go over it again. We've got the header files, input output header files. We've got the main function. There's a lot. Have we declared the variables? Let's see. We've got n. We've got bk. Then we've got r, d, bk, and n. Okay, got it. So we'll close it now. Then we have printed a message to enter a number. We enter a number through scanf. We've taken a backup of the number so that we don't want to change our original value in n. In backup, we are doing our operations on bk. We've given a condition while bk is not equal to 0. We'll gonna run until our bk is equal to 0. That's the statement will be when this statement is false, it'll stop executing. So we have input a number 121. It's not equal to 0, so it will go in. Then we're extracting each digit in d, and then we're adding it in r so that we can get a reverse of the number. And then we're removing each and every the last number that we are extracting from bk. Then what we're doing is we're checking, it's a checking condition, if statement, checking if the reverse number, that is r, is equals n, that's the original number, If it is true, then we'll print a message. This number is palindromic. Else, we'll print a message, a caution message. The number is not palindromic. So we've done it. So just to check whether code is right or wrong, we'll just copy it. And we'll run it. And in our ID. Okay, let me just get it. Yes, remove the extra comments. We don't need to just leave it there. So I think we've got it. And let's just run it now. And what we'll do is we'll compile. Then we enter a number. Let's say we had worked with the example of 1 to 1. Let's say I've input a number 1 to 1. Oh, and then we enter it. The number is palindromic. Next number palindrome. Let's check with another number that is not a palindromic. Let's say we're compiling it, enter a number. Let's say if we've input a number 1, 2, and 3. The number is not palindromic. Voila, you've done it. You've done your palindromic code. So put a pat on your back because you've done it.